What's up, guys? So I remember I like to talk. Okay, so today we are going to be dealing with MTS 421. I really don't know the code you are using in your various institutions. You can be using MAT 421, MAT 412, and anyone is fine. So today we are going to be dealing with Laurent series expansion. So basically, I got to realize that a lot of students used to have issues when it comes to Laurent series expansion. So I'm going to bring everything towards pieces so that you can get the real concept of it. Alright, so we have the first question here. So believe me, if you want to deal with Laurent series expansion, you have to remember or recall reference to your topic, partial fraction. So if you don't know your partial fraction, go back to it and understand the concept. No sweats. But now we go this way. Alright, so we have the first question, Q1. Expand the analytic function, that's f of z, is equals to 1 over z plus 1, then z plus 3 in a Laurent series valid for the region 1 less than z less than 3. Alright, so let's solve this problem. This is Laurent series expansion. So expand the analytic function f of z is equals to 1 over z plus 1 and z plus 3 in a Laurent series valid for the region 1 less than z less than 3. No stress. So all you need to do is, let me give you just a logic. The rules say that anytime you're having all these boundaries, like when you're having this kind of boundaries, just make sure that whatever you're having should always be less than 1. Okay, let's go. Alright, solution. What is the first step? The first step is that bring this guy out. You're having f of z is equals to 1 over what? Z plus 1, then what? Z plus 3. So you have to resolve f of z into partial fraction. Into what? Partial fraction. No stress. Now let's resolve this guy into partial fraction. We are having what? Z plus 1, then z plus 3, all equals to a over z plus 1 plus what? B, then z plus what? 3. No stress. Now we now take our what? Take your LCM is equals to what? Z plus 1 and z plus 3. Alright, so if your LCM is this, what happens? So you now be like 1 over what? Z plus 1 z plus 3 equals to z plus 1 z plus 3. Alright, when this one divides this, we are left with a into what? Z plus 3, then plus b into z plus 1. No stress. Then from this place, you can see this one will take care of this. We are left with what? We are left with 1 is equals to what? A into z plus 3 plus what? B into z plus what? 1. We are trying to rewrite this analytic function to a simplex form. Alright. So when we get to this junction, what happens? You put your z is equals to what? We can start up anywhere. We put our z equals to what? 1. So when your z equals to 1, what happens? So we have what? 1 equals to a into 1 plus 3 plus what? B into 1 plus, oh, I'm sorry, z equals to minus 1 rather. Sorry about that, there's a mistake. So if z equals to minus 1, we have then 1, this is minus 1 plus 1. Are you with me? So this is also minus 1 plus 3. So this one becomes 1 equals to minus what? Minus 2a. I mean, this is 2a rather. So this one is 0, okay? Which implies that a is equals to 1 over 2. Alright, we go further. So we also say put z equals to, from this place, we can say z equals to what? Minus 3. So which we say that what? Substituting it here, we have what? 1 equals to a into what? Minus 3 plus 3 plus b into minus 3 plus what? Plus 1. So at the end of the day, we're having 1 is equals to what? Equals to minus 2b. Do you agree with me? Which implies that b is equals to minus half. Alright. So now our partial fractional becomes, thus this one becomes this f of z, which is a over z plus 1 plus b over z plus 3, now then become, it's now become what? It becomes, what is our a? Our a is 1 over what? 2 into z plus 1. Alright, so minus times plus is minus. We have 1 over what? 2 into bracket z plus 3. No stress. Alright, at that junction, we now get to know that f of z equals to 1 over 2 is common. We can bring it out. Alright, so we are left with 1 over z plus 1 minus what? 1 over z plus 3. No stress. Alright, we are getting along. No stress. Alright, so now, what is the next thing we are going to do? So when we get to this junction, there's something you need to understand when we get to this junction. So you now see that, given what? Given the boundary to be 1 less than z less than 3. Alright, don't forget what I told you. I told us that it must always be expressed like this. Anything you have, this k must be less than 1. So the k will represent your z, whatever you have with respect to your z, less than 1. So at this junction, this one implies that, it implies that we have 1 less than z, and we also have what? Z less than what? 3. That's what it implies. So if you break this one down, it means 1 less than z, and also z less than what? Z less than 3. So now, if you now rewrite this one, you know this one, and you want to write, don't forget the law. So this one can be rewritten, we can write this one to, remember less than 1, we can rewrite this one to what? 1 over what? Z less than 1. This one as follows the condition of this guy that I wrote here. So as well as, similarly, we apply the same thing here. This one also follows that what? Z over 3 less than 1. Do you agree with me? No stress. So if you agree with me, you will know what I'm talking about. So every case, this boundary, by the time you split this boundary, at the end of the day, each case of the boundary must be less than 1. That is the protocol. Now, see where it is applicable. No stress. So now, we are now going to be applying these two boundaries to this side, okay? No stress. So this one goes for this first fraction, while the second one goes for this. So you see, we can see 1 here. We can see this 1 here. We can see this 3 here. So we apply it there. Then our f of z equals to 1 over 2. Alright. So we can rewrite this guy as, you know that we have 1 over z here. So since we have 1 over z here, then z comes out. Z into 1 plus, we can rewrite this one as 1, okay, z into, okay, 1, then 1 over z. You agree with me that if I expand this guy, it's going to give me this one back. So which means that, but what we have here is still the same thing as there. You have to find a way such that this one will be appearing inside this denominator. You also have to find a way that this guy will be appearing inside this denominator. It is very simple as that. Alright. So you will also agree that now we are having minus here. Let's sort this one. Let's do it such a way that this z over 3 will be appearing into this one too. So we now have what? 1 over, well, how can we do it? Let's look at it critically. What if we say z into 3, okay, z into 1 plus, alright, 1 over, we have 3 here. By the time we expand, z times 1 is z over 3. Okay, that means this one is not going to work out. It's 3 that's going to be out. What do we say? 3 into z. Okay, 3 into 1 is going to work out. Sorry, we have to be very careful. 3 into 1 is 3. So 3 into this one will give us this one. You can see it is perfect this way. No stress. So that is what I'm talking about. So you try to think critically. You have to find a way of solving it that this guy, this one here is going to be existing in this denominator. That is how it works. Alright, at this junction, you now agree with me that we can write this guy as 1 over z, which is into, okay, we can rewrite this one as z into 1 plus 1 over z raised to power minus 1. Alright, minus, we can also rewrite this guy as 3 into, we can remove this one away, as 1 plus z over 3 raised to power what? Minus 1. No stress. You will agree with me. So, the other rule is now that when you get to this junction, you see 1 over 2 is common there. So, you now bring this one outside. So, now, you will see that z into, whenever you have 1, you see this minus, is going to affect this one here. So you will repeat this one as the case of the Laurent series. So instead of writing 1 plus 3 here, it is just anytime you have it, either writing 1 plus, you now have, instead of writing 1 plus 1 over z, you now have 1 plus 1 minus. This minus here have affect this one to be negative. So 1 minus 1 over z, then continuously plus minus 1 minus 1 over z is meant to be 1 square, but 1 square is still 1. Then continuously 1 over z square plus 1 over z cube. This. So, alright. So I hope we don't have any mistake there. Oh, sorry. This one is going to be 1 over z. Please let's sort out the error. This 1 over z, because 1 over z multiplied by 1 over 1 plus 1 over z is still going to give us back this one. So sorry, let's correct that mistake. This is still 1 over 3. Alright. I believe we are together, so no errors like this. So at this junction, so we can still continue further. Alright. 1 over 3. So this one, don't forget, regardless of the sign. So this one is 1 plus 1 over z. So we started with 1 minus 1 over z. The rest will now continue. So this one, so don't let us make any mistake. So I'm trying to make sure we get the final answer. So this is 1 minus 1 over z plus 1 over z squared minus 1 over z cubed. So now this one like this now, what are we going to start with the idea of this one? You know this one was 1 plus 1 over z. We will now use it to start with 1 plus 1 over z. We use it to start with 1 minus 1 over z. So since this one is 1 plus z over 3, so we use it to start with what? 1 minus z over 3. So we now be continuing like that. Plus minus plus minus. So this one begins with 1 what? 1 minus z over 3, okay, plus z square over 3 square. You know, here I said it's supposed to be square, but it's still going to give us 1. Then it follows like that. Alright, plus, okay, this one is going to be minus z cube over 3 cube, then plus dot dot dot. You can end it this way. So if you like, you can leave your Laurent series like this. We can leave your Laurent series like this, but you can break it down. This is our Laurent series, so we have expressed it as a Laurent series expansion. So if you like, you can break it down. So by the time we break this guy out, so what do we tend to have? We have what? 1 over 2z minus 1 over 2z square plus 1 over 2z cube minus 1 over 2z4. So plus dot dot dot. Okay, then you can have it like this. Alright, so this guy too, you continue further here. So this one gives us what? 1 over what? 1 over 3. Then plus what? Plus z over what? 9 minus z square over, this one is 9 times 3 is 27 plus 27 times 3 1 2, 6, 7, 8, 81, right? So that is 7 cube. Z cube over 81 rather, plus dot dot dot. Sorry, this one is meant to be minus. Alright, so I think we are on the track. So we can now solve it normally actually. So we are going to start with the minus side of it and arrange it in a way. So you can leave your Laurent series like this, or you can write it this way, like we have one here. You can write it as minus 2z raised to power 7. So this is it. You can start from here. You start from the negative of z up to the positive. You can start with this minus, then pick other minus, then plus in front of it. So you can leave your Laurent series like this, no stress. So it is very easy that you can ever imagine. That is Laurent series example for you. So I want you guys to leave, it's just a line remaining. Leave the final answer you feel that this one should be. Drop it in the comment section. You can snap it and crop it and drop it in the comment section. That's all about Laurent series. No stress. So we're moving on to residue of calculus. I love you guys.